Hi students, so welcome you all. In this bridge course class, I am going to take the concept of polynomials, and in this polynomials, first let us see the definition of polynomial and the examples of the polynomial, different types of the polynomial. Okay, so in this polynomial, first let us see the definition of polynomial, that is an expression of the form f of x equal to, you just see here, an expression of the form f of x is equal to p naught x to the power of n plus p1 x to the power of n minus 1 plus p2 x to the power of n minus 2 plus so on plus pn is called the polynomial. Okay, or it is said to be an expression of the form p naught x to the power of n plus p1 x to the power of n minus 1 plus p2 x to the power of n minus 2 plus so on to plus pn is called polynomial. Okay, so here you can just see where n is a positive integer, where n is a positive integer. Are you getting my point? You can't get any negative numbers as well as rational numbers. N must be positive integer. And you just see p naught must not be equal to 0. See this. P naught must be not equal to 0. Okay. So therefore p1, p2, p3 are real numbers is called polynomial of the degree n in x. That means here x is variable. Okay. So quickly you can just remember the polynomial is an expression of the form p naught x plus p1 x to the power of n minus 1 plus p2 x to the power of n minus 2 plus p3 x to the power of n minus 3 plus so on to plus pn, where n belongs to integers, that is positive integers, as well as p naught, p1, p2, p3 so on to pn are real numbers, okay. So therefore the expression and this type of expression is called polynomial in the degree n, with variable x, okay. So here first you can just see the highest power of x is called degree of the polynomial. See, the highest power of x in the polynomial is called degree of polynomial. Okay, so the degree of the polynomial means the highest power of the equation of the variable x is called degree. Clear? So for examples, here you can just see p naught is called the leading coefficient. And next let us go for the example. See here, ax plus b, ax square plus bx plus c, ax cube plus bx square plus cx plus d, so on. These all are called polynomial. Here the degree is 1, here the degree is 2, here the degree is 3. Okay, see that degree of the polynomial is 1, here the degree of the polynomial is 2, here the degree of the polynomial is 3, because here 3 is the highest power of the variable x, here 2 is the highest power of the variable x, here 1 is the highest power of the variable x. Clear? So this is about the definition of the polynomial, the degree of the polynomial, and the examples on the polynomial. So on this, let us go through one of the problem, that is, which of the following is not a polynomial and why? Here you first see the first option is x cube plus 2x square plus 5x plus 6. Second option is x raised to 4 plus 5x cube plus 3x square plus 5x plus 7. And the third option is x square plus 7x plus 8. And fourth option is x to the power of 2 by 3 plus 7x plus 8. So they are asking which of the following is not polynomial. So here you can just see the power of x is rational number. The power of x is rational number. So clearly you can say that this is not polynomial. Okay. So fourth option is not polynomial because of the power of x. Here the power of x is in the form of p by q and we say that is rational number. Therefore fourth option is not an polynomial. Okay. So quickly we can move to the next problem. So before going to the next problem, you can just see the solution, that is in this polynomial the power of x is not integer. So this is not integer. Okay. So that's why the fourth option is not polynomial. Clear? Okay. See the next problem. Which of the following is not polynomial and why? And you have four options. The first option is x cube plus 2x square plus 5x plus 6, x raised to 4 plus 5x cube plus 3x square plus 5x plus 7, 3x square plus 4 by x plus 8, x square plus 7x plus 8. So here you can just see the power of x is minus 1. If it is given as 4 by x, we can write it as 4 into x to the power of minus 1. Okay. So minus 1 is not positive integer. Minus 1 is not positive integer. So therefore option 3 is not polynomial. Option 3 is not polynomial. Clear? So here clearly you can go through it and you can understand that is option 3 is not polynomial. Okay. Why? Because of this 4 by x. 4 by x means we have to write it as 4 into x to the power of minus 1. So therefore minus 1 is not positive integer. Hence option 3 is the right answer where it is not an polynomial. Okay. So now quickly we can go for linear polynomial. Linear polynomial means a polynomial of degree 1. A polynomial of degree 1 is called linear polynomial. A polynomial of 1 is called a linear polynomial. Example. You just see the example x plus 3. Here the power is 1. Therefore this is having polynomial of degree 1. See here also power of x is 1. So therefore this is also linear polynomial. Clear? So therefore the linear polynomial means a polynomial of degree 1 is called linear polynomial. I can also write it as 2x plus 3. I can also write it as like 2x plus 3a. Okay. So here x is x is variable, 3a is constant. Okay. So therefore linear polynomial with degree 1. Linear polynomial means it is with a degree 1. Next you can go for quadratic polynomial. Quadratic polynomial means a polynomial of degree 2. A polynomial of degree 2 is called quadratic polynomial. So you can see here it is having degree 2. The highest power of the variable is 2. Therefore you can say that this is quadratic polynomial because degree is 2. Here also you can see that 5x square plus 7x plus 15. X square means you have 2 as the degree. Therefore it is called quadratic polynomial. Next we can go for cubic polynomial. So in the cubic polynomial you can just see the degree is 3. Okay. So therefore 3x cube plus 5x square plus 7x plus 10. So cube. Okay. So here you have degree as 3. Therefore this is cubic polynomial. Therefore this is cubic polynomial. Okay. Why it is cubic polynomial? Because of the degree 3. And on the same way 7x cube plus 4x square plus 6x plus 15. Here you can see that highest power is 3. So therefore degree is 3. Hence it is cubic polynomial. Okay. So now I think you got what is linear polynomial, what is quadratic polynomial, and what is cubic polynomial. Now we can go for biquadratic polynomial. A polynomial of degree 4 is called biquadratic polynomial. That means the highest degree is 4. The highest degree is 4. Is called biquadratic polynomial. Biquadratic polynomial. Okay. So therefore because of this degree we say it as biquadratic. Clear? So now we have gone through linear polynomial. Now we have gone through linear polynomial. Next quadratic polynomial. Next we gone through cubic polynomial, and next we have went through biquadratic polynomial. Okay. So here the degree is 1, here the degree is 2, here the degree is 3, here the degree is 4. Okay. So now quickly we can move to the next concept, that is constant polynomial. The constant polynomial means degree is 0. So you can write 3 and 4. 3 is constant polynomial, 4 is constant polynomial. Because if you write 4x to the power of 0, x to the power of 0 is 1, 4 into 1 will be 4. So here the degree is 0. So that's why the polynomial of the degree is 0 is called constant polynomial. Clear? Okay. So now we can go for polynomial equation. Means here an equation f of x equal to 0 is called an algebraic equation or a polynomial equation when f of x is a polynomial in x. Okay. So f of x is polynomial, and it is equal to 0. This type of representation is called either algebraic equation or it is called polynomial equation. Okay. So now we can go for the examples. That is 2x raised to 4 plus 5x cube minus 3x plus 5 equal to 0 is polynomial of equation in degree 4, and 2x cube minus x square minus root 3x plus root 10 equal to 0 is a polynomial equation of degree 3. Okay. So therefore now I think you got what is polynomial equation or an algebraic equation. So any algebraic equation or a polynomial equation written as equal to 0 in the form of f of x equal to 0 is called equation. Okay. Now we can go for quadratic equation, that is an equation in the form of ax square plus bx plus c equal to 0 where a, b, c are complex numbers, and a is not equal to 0 is called quadratic equation in variable x. The numbers a, b, c are called the coefficients of the equation. Okay. So now you just see here, quadratic equation means it is in the form of ax square plus bx plus c equal to 0. A must be not equal to 0. X is variable. A, b, c can be your complex numbers or also real numbers, no problem. So is called quadratic equation. Okay. Here you can see a is a leading coefficient. Of the equation, and the leading equation of the coefficient must be always non-zero. Okay. So examples, you can just go through these things. These are the very simple examples that you can go through these things. That is 2x square plus 3x plus 7 equal to 0. And the next one is root 2x square plus 3x plus root 7 equal to 0, x square plus 6 equal to 0, x square plus 5x equal to 0, x square equal to 0 are quadratic equations. Okay. So next you can see roots of quadratic equation. Roots of quadratic equation means a complex number or a real number alpha is to be a root or solution of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c equal to 0. That means alpha is going to be the root. If I substitute it in x, it must be equal to 0. Okay. If I substitute alpha here, that is going to make this particular equation as 0, then alpha is called the root of the quadratic equation. Okay. So here 2 is the root for quadratic equation x square minus 3x plus 2, because you just see 2 square minus 3 into 2 plus 2. Here 4 minus 6. 4 minus 6 is minus 2 plus 2 going to be equal to 0. Therefore 2 is the root of x square minus 3x plus 2 equal to 0. The zeros of the quadratic equation ax square plus bx plus c are the same as the roots of the quadratic equation ax square plus bx plus c equal to 0. That means roots are also called as zeros. Roots are also called as zeros. Okay. So now according to the fundamental theorem of the polynomial, you can just see the nth degree polynomial equation has n roots. Example, 2x raised to 4 plus 5x cube minus 3x plus 5 equal to 0 has maximum 4 roots. 2x cube minus x square minus root 3x plus root 10 equal to 0 has maximum 3 roots. Okay. So now from this you can understand that nth degree polynomial equation has at most n roots, not more than n. If it is cubic root, it may have 3 roots. If it is biquadratic equation, you have 4 roots. If it is linear equation, you have 1 root. If it is a quadratic equation, it has maximum 2 roots. Okay. Clear? So like this, what is going to be the degree of the polynomial? So based on that many number of roots or that many number of zeros, that particular equation are going to represent. Okay. So with this, in the next class we can continue with forming of the polynomial and all. So if we complete forming of the polynomial, our polynomial topic will be completed. So no problem. Okay, now only we can go with forming of a polynomial equation. So see here, forming of a polynomial equation means a polynomial equation having alpha comma beta as roots. Now we can write it as x minus alpha into x minus beta equal to 0. Because we have to make an equation by using this alpha and beta. So if I want to make quadratic equation or a polynomial equation by using alpha and beta, so I can write it as x minus alpha into x minus beta equal to 0. So now this is going to be one polynomial, that is by multiplying x minus alpha and x minus beta. Okay. So next you can see that alpha, beta, gamma are the roots. That means we can write it as x minus alpha, x minus beta and x minus gamma equal to 0. So that is going to be the polynomial equation by using 3 roots. So like this you can form the polynomial by using the roots or the zeros. Okay. So now using the example, see here, if I have 2 and 3 are the roots of one polynomial equation, so I can write it as x minus 2 into x minus 3 equal to 0, So this is going to be x square minus 5x plus 6 is going to be equal to 0. So see that this is a polynomial of quadratic equation. Okay, so that you got here, x square minus 5x plus 6. Clear? On the same way, you can see the another example by taking the roots 1, 3 and 5 as roots. Now I can write it as x minus 1 into x minus 3 into x minus 5 equal to 0. So now if I multiply those terms, x square minus 4x plus 3 into x minus 5 will be equal to 0. If I multiply these two terms, we will get x cube minus 9x square plus 23x minus 15 equal to 0. So here this is going to be the polynomial. This is going to be the polynomial with cubic root. Okay. So now with this I will end this session on the polynomials. So from this I can think you can learn about the polynomial, what is the polynomial, examples of the polynomial, and what are the roots of the polynomial. Roots are called as zeros of the polynomial. So these all things you can learn from this session. So in the next session we can go with some new concept which will be the basics for your further studies. So thank you everyone. We can meet in next class.